Reno, southwest end of town, southeast end of town eventually, maybe. Very fast-moving fire, pretty intense, very dry. There's a lot of wind, and it doesn't look like the wind's going to quit for at least another 6 hours or so. So this is a very potentially damaging fire that can unfortunately get very close to houses. So it's a sad day for Reno. It's amazing what difference a day can make to the weather. Yesterday we had the incredible winds that were fanning the flames of the fire that was climbing up the hillside up this way because of the heat and the convection, and the wind was blowing the embers back down and all around and dropping all of the embers all over the place to make a firestorm of epic proportions. Very sad, but it was fantastic that the people working on saving the houses did a very good job. You can see the blackened area in here, and then the houses here that were saved from getting torched by that crazy fire. The situation is that we had this cold front pass, and it brought cold air. This is the wind data that was provided on the day of and near the day of the fire that occurred. The wind data is provided by the Western Regional Climate Center of the Desert Research Institute. This data was obtained at the Wolf Run golf course south of town, and what it shows is that for a large proportion of the time, very strong winds were coming from the west-southwest, and that during a substantial fraction of that time, the winds had magnitudes in excess of 40 miles per hour. It was a very damaging wind event. This graphic shows the area in Reno that was burned in the fire. For reference, this is southwest Reno, where the red area is the area of the fire. Downtown Reno is over here. This is the area where the fire apparently started. These are upscale housing area right in here. And keep in mind from the last graph that the winds were from the west-southwest during the passage of that strong frontal system, and that there's larger mountains over on this side over here, and it gets more shallow as we move into the valley, Reno Valley, Truckee Meadows Valley, in this direction here. So basically the problem is that the winds are going to push the fire one way, and then the convection and the heat associated with the fire is going to tend to push the fire uphill. So for example, in the beginning, I suspect what's happening is that the wind, or the convection and the heat, are pushing the fire uphill in this direction, and then the wind blows the embers from the fire downwind over in this direction. So those hot embers start secondary fires in other locations, and so then when those hot embers hit over in these areas, they've caused some of the problems with some 30+ houses that were burned in the overall area. So the uphill motion of the fire is caused by the convection. The motion counteracting it is from the winds that's blowing the hot embers around. So it's sort of a zigzag pattern of fire climbing this way, winds pushing embers this way, fire climbing this way, winds pushing embers this way, and so forth, and causing this fire to spread in a very erratic and unusual fashion, where places where you wouldn't think would be associated with the fire, like over here, were so because of the embers that were flying off of the fire. It was very strong winds that were both amplifying the fire and blowing the hot embers around.